Okay. Did we have homework? Oh, deathmatch thing, the code side of it, right? All right. How'd that go? How do we describe a train wreck? The homework. I heard the homework was too easy. I'm almost always being sarcastic. The it's a so let's go ahead and look at it. Let's see if I can figure out how to do it. Um, okay, what did we write so far? Okay, so we started with this fight scene thingy. Fight scene manager. Okay, so this is our mono behavior. It lives in our scene. I'm just catching myself up here. It lives in our scene. This guy creates an instance of this dude called fight. Let me hide these meeting controls so I can see. Okay, so this guy creates this instance of this thing called fight. What is a fight? Fight is a collection of two inhabitants. We wrote inhabitant last time, which we created as an abstract class, right? Abstract classes are classes we cannot create instances of. Um, so they exist with the idea that we're going to create other classes that inherit from them. And we did. We went back to our player and we said, player, you are now an inhabitant. So it gets the inhabitant stuff. We then invented this thing called a monster, which also is an inhabitant. Therefore, if we look at our fight scene, the attacker and the defender can be either a player or a monster. The reality is one of them would likely be the player, the other one would be some monster that they're fighting. Right? If we move sometime in the future where we start allowing PvP, they could both be players or whatever. Or if we want to just have fun and have monsters attacking each other, they can both be monsters as well. Okay, so when we instantiate a fight, we are initially figuring out who goes first. So we can throw a little comment in here if we want. Um, call this initially determine who goes first. Oh, it even finishes. What? I'm hitting tab. Haha. I kind of like that feature. Way less misspellings. Um, I wonder why they don't have Hawaiian Punch on the spigot in the cafeteria. Hawaiian Punch is so good. You just remember from like when you're 6 years old drinking Hawaiian Punch. All right, so I drink about a gallon of it a day. It's the fake sugar kind, so it's going to give me other health problems, not too much sugar. All right, so we're going to determine who goes first based on this random roll 1 through 20. Um, if it's less than or equal to 10, we decide randomly the monster goes first. Otherwise, we decide the player goes first. Now, realistically, we already have access to the player, right? The player is stored up inside of core, our singleton, this dude up here. So we already have this object up there called the player. For our intents and purposes right now, I think we can make the assumption that the player is going to be one of the inhabitants involved in this fight. All right. So what that means is that when we create a fight, we probably need to pass in who's involved in this fight. We can make the assumption that one of them is the player. So we don't need to have that passed in. So really a fight is between the player and some monster. All right. So that means whoever created this fight, let's actually go ahead in here and why don't we say we're going to take in a monster M as part of the constructor for our fight. So whoever instantiates this fight is going to pass in the monster that the player is going to be fighting with. All right. What we can go ahead and do initially, well, we can actually just do it. We'll do it inside the if statements. So if the monster should go first, then what we're going to say is we're going to say this dot attacker is equal to M. this dot defender is equal to core dot the player. That's where our player lives. Otherwise, if the player goes first, we'll say this dot attacker is equal to core dot the player. This dot defender is equal to M. All right. So when we come out of this if-else structure, the attacker is set to whoever's going to be throwing the first punch. The defender is set to whoever's receiving the first punch. And then as the fight goes on, we'll be rotating those guys around. Okay. So let's go back to inhabitant here. I see a chat. The pink one's the best. What was my question with that? Oh, Hawaiian punch. Oh, but the worst one, I don't know if I've had the pink one, or at least not recently. My wife bought me this like I don't know, mixed berry. It was a bluish purple box. Oh, terrible. Barely could choke it down. I may have put some additives into it after I got home from school. All right. What is the pink flavor? Like pink lemonade or something? Oh, oh, you think it sucks? No. Well, this is the plain Jane, whatever Hawaiian punch red. I don't know if they even say fruit punch. I think it's just red. Okay. So when we're done with this if statement here, the attacker is set to the correct inhabitant and the defender is set to the correct inhabitant. All right. So our lesson here that we want to connect the dots with, because we're kind of going back and throwing ourselves back into this inheritance model, understanding that we're using this generic idea of an inhabitant to hold on to more real objects, to hold on to players or monsters, both of which are inhabitants. Make some sense? All right, and we're going to have to look at how can we tell them apart potentially later on. So let's go and look at what we wrote in inhabitant so far. So last time we invented this inhabitant, we decided, okay, this guy's going to be abstract because we're never going to actually create instances of inhabitants. Instead, we're going to have monsters and players running around who share these attributes. So we decided inhabitants have current hit points, a maximum hit points, an armor class, and a name. Those things get set to some random junk, whatever. We'll come back and put our getters and setters in here in a few minutes as our fight unfolds and dictates for us. All right, so here in our fight scene manager, our mono behavior that's in our Unity fight scene, when we create this fight, we now need to have a monster that's going to be doing this fight. Okay, so let me go to monster real quick and see that when we create an instance of monster, all we need is a name. All right, so whenever a fight starts in this scene, I'm going to go ahead and I'm going to have a private variable up here, private monster, the monster. And in the constructor, effectively the constructor for a mono behavior is the start function. This is the thing that gets called one time when the scene spins up. We'll go ahead and create the monster. Ha. I guess the AI thinks it should be a goblin. All right, so we're going to create a goblin. I'm starting to find it entertaining. All right, so we'll create a goblin. Then when we actually create our fight, we'll go ahead and pass in our monster. So now we are creating our fight correctly based on what we're doing. Let me hide this again so I don't accidentally stop sharing. All right, so when we create a fight, we pass in the monster. The monster is going to get set to either attacker or defender. If we really wanted to, we could give ourselves the a pointer to the monster as well up top. So I'm going to go ahead and do that. It might be handy here in a little bit. So I just threw a extra private variable up there for monster. I just set it equal to whatever monster was passed in. That way we have a quick and easy way of just grabbing the monster involved in this fight, and we don't have to ask, was he currently the attacker or the defender? Right? Because we do have the ability of saying, is the attacker a monster? If yes, he must be the monster. Else, the defender must be the monster. Now we just have a convenient way of just talking about the monster through this one variable. All right. But ultimately, we're going to set the attacker and the defender appropriately based on this random roll. Now, when our fight starts, this is when we're going to go back and forth between these guys until somebody kicks the bucket. All right. So we know by the time we start this fight, the constructor's already been called for fight. So after this line is done, internally in our fight, we have an attacker and we have a defender. We've determined who's swinging first. Actually, I'm sorry, after this line, we've determined who's swinging first. Then we tell the fight to go ahead and start. So that is this function down here that we were to write for today. All right, so now we determine, well, how do we decide if somebody is going to hit someone else or not? We'll just kind of go through normal, dumbed down D20 rules or something like that. Remember, our inhabitants have an armor class. So what we can do is we can roll a D20, 20-sided die. I'll go ahead and steal our little random range thing here. Remember, that's inside of it, Unity engine. We have both system and Unity engine here. Let's see, I need to be in fight. What do we have in here? We have Unity engine. Okay. So we'll go ahead and we're going to create a number. So int attack roll is equal to random.range 0 to 20 plus 1. Is it going to do the whole stupid thing? All right. So then we're going to ask our attack roll. Well, actually, this will be a good thing. We'll ask our attack roll, did the attack roll clear our defender's armor class? Well, right now, we cannot get to the defender's armor class because we don't, inside of inhabitant, these are all protected, which means they're only accessible from inside the inhabitant class or inside of the children of inhabitant, which is either player or monster. Right now, we're trying to access it from within fight, not one of those other two, one of the other three. So we're going to have to give ourselves a getter for that. So we'll say public int get AC, and this will return the armor class. All right, go back to fight. So we'll ask the question, if the attack roll is greater than or equal to this dot defender dot get AC. So, and it's called attack roll, not attacker. So if our attack roll is greater than or equal to the armor class of the person we're trying to hit, that means we hit them. And if we hit them, we're going to go ahead and roll damage. And let's see, AI thinks we should have damage between 1 and 6 or 1 and 5. I can roll with that, I suppose. So we need to generate the amount of damage we're going to do. Then we need to have the defender take some damage. Well, we don't have the ability to do this. This is effectively a setter for our current hit points, right? So we're going to have a function here called take damage that we're going to write inside of inhabitant. This will be public. It's going to write it for me. It's just completely stupid. All right, so take damage is going to take in an amount of damage. We will then subtract that damage from our current hit points. We'll ask the question, are we dead? Did we just die? If we just died, we are writing something out saying we've died. I'm probably actually going to take that part out. We're going to keep this kind of simple for the steps. We'll tell the opponent to take the damage, the defender to take the damage, then we'll check on him. Are you dead? All right, so let's go ahead and write a is dead. And that's going to return whether the current hit points is less or equal to 0. Now remember, we also remember our max hit points. So if at any point in time we need to take a health potion or something, we can recover our hit points up to our max hit points if that was something we needed to know in the future. But right now we're just operating off of our current hit points. All right, so we have the ability to ask an inhabitant, are you dead? Go back to our fight. We generate, so if the attacker hits, so we can say attacker hits the defender, we'll go ahead and generate some damage. 1 to 5 is fine, because I think we determined last time 1 is inclusive, the 6 is exclusive. So this is an amount of damage 1 to 5. So 1 to 5 damage. We'll tell the defender to go ahead and take the damage because the assumption is the attacker is the one who did the damage. We don't have to ask the attacker for damage at this point, because we're not differentiating the amount of damage that's being done. Maybe later on, if we had wizards that had really low armor class and higher damage output, we would want to ask specifically, give us your damage. But in this case, we'll just assume everybody's throwing fists and it's the same amount of possible damage the monster or the player can do, just randomized. I'm going to get rid of these debug things for now. All right, so we'll generate the damage. We'll tell the defender to take the damage, and then we'll ask, did the defender just die? Okay. If this dot defender dot is dead, then we have a winner, right? Print. Bug.log, this dot attacker get name, which we don't have that yet. Killed, defender get name. Fine. We can roll with that. So in order for this to not have the red squiggly, and I bet you, what is it? I hover over it, it just writes it for you. Quick fix using Copilot. All right, so we're going to write a function called getName, which is effectively going to be our getter for inhabitant to give us the name of that inhabitant. So we'll go back into inhabitant. We'll create a public string getName, and we'll return the name of this dude. That's a nice, helpful thing for those kind of things. I like that for the Copilot or whatever. All right, so that'll give us the name of this inhabitant. Back here in fight, we're just going to output whoever was attacking, get his name, then say they killed whoever was defending, get their name, and effectively this fight is now over. All right, we'll have to decide how do we end the fight here in a second. All right. Otherwise, if the attacker did not successfully hit the defender, meaning they didn't clear their armor class, then we could say the attacker missed the defender. Okay. Now we want to keep doing this basically until someone dies. So we're going to wrap this entire thing inside of a while loop. So while true. So while true, generate the attack roll, decide if we hit or not, possibly kill him, check if he died, yada, yada, yada. All right. If he did die, we don't want to fight anymore. So we're going to go ahead and break out of this loop. Fight is over. All right. Otherwise, we're just going to say that you missed, give some a little commentary, and now we need to do a switcheroo, right? We need the defender to now become the attacker and the attacker to now become the defender. So we'll say inhabitant temp is equal to the attacker. The attacker becomes the defender. The defender becomes temp. Oh, I actually do. All right, so we need a little temporary inhabitant to hold our attacker for the time being when we're overwriting our attacker with a defender. Then we can copy over defender with temp, which is holding our old attacker. All right, so when this is said and done, once we spin back up the top of this loop, the attacker and defender have now switched places. Okay, they're both still inhabitants. We're just going to keep going back and forth until someone dies. All right, I think this solves the homework. All right, let's go see what we broke. So when this scene first launches, we have our fight scene manager. Fight scene manager goes ahead and creates a monster, starts a fight. Well, creates a fight, starts the fight, which then should have all this stuff go off. So we'll go ahead and hit play. Oh, this guy's not happy about something. Object reference. This dot defender. What's he complaining about? Object reference not set to an instance of an object. And it's talking about that right here. This dot defender dot get AC. We set the defender there. We set the defender there. Why would it not be set? Back here. When we start this guy, we create our monster, start our fight, pass in the monster. Monster comes in here. We remember our monster. We roll the dice. We set the attacker and the defender here. We set the attacker and defender here. Inside of our start fight, that guy should have value. Is all this saved? It's possible we didn't save something. Ooh, well, where are we creating the player? We create the player. Oh, actually, why are we getting this problem? Anybody know? When does our player get created? Remember, we're just launching the second scene. We're launching the scene that involves the player having gotten into a fight. Well, the player gets set back on the first scene, right? So for right now, we're going to have to fake it since we haven't made the thing to get us over to this thing. Go ahead. Not make a new constructor. What we'll do is inside of core, we'll go ahead and set the player equal to a default player. So we'll say new player, Mike, something like that. All right, so now we're guaranteed that there'll be a player. One thing we could do here, just to make this something that we don't have to go back and fix later, is I can stop this, go to project, go to our room manager, that original guy who started our dungeon. Our dungeon, I think, oh, here's our player right here. So we're just replacing that by moving that code up into core. So it happens always. So no longer are we going to have our room manager from the first scene actually be the one who gives birth to the player. Now the player has just always existed before the game even starts. So we'll just take that one line out from room manager. All right, so now when we go back in here, since we're only launching this second scene, it's going to have our player from core. All right, let's see who won. The goblin killed me. is what just went down there, which is unfortunate. Um, yeah. Let's see if I win the second one. I am having a rough go at things here. Ah, I killed a goblin that time. All right, so I think that's the solution to the homework. That sound like we covered everything. Okay, so questions about that before I keep going on. Right. And then an interesting thing we just saw that you keep in the back of your mind that as you're building your games and you're testing stuff, know that if you just launch one scene, you're not gaining the benefit of what other scenes may have done to some of your objects. So in this case, it was an easy enough fix. We just had to say the player has just always existed. So we have the player available to us no matter what scene we start with. But before, the player was born in that very first scene. So if we bypass that very first scene, we would never have a player. Just something to keep in mind as you're working on components of your game, testing that before you integrate it into the larger game. Go ahead. Yeah, so the question for the online folks was if we do have a game where we have several scenes and one scene is dependent on another scene having occurred, would you have to play through your game to get, which gets annoying really quick, by the way. Would you have to play through your game to make sure you got the right setup? Well, the answer is yes, unless you put in a little bridge where you faked coming out of that scene for a temporary time period so that your code in the scene you're working on is as if you had come through the previous scene. So you might have to hard code some settings, just make sure that, okay, well, this guy exists like the player, that kind of stuff. But also then remember that you're going to have to take that back out once you or comment it out or something like that once you're ready for actual play testing so you can get to the scene under natural natural causes instead of forcing it. Okay, so we have our game now going back and forth. We know who wins and who loses based on what's popped up on the screen so far. So, what should we do next? Probably have one of these guys disappear when he loses, something like that. I mean, obviously, we'd want to have like this giant aggressive death scene and all that stuff, but I'm not that talented at art, so we're just going to have somebody disappear, is what's going to happen, and the fight will be over. Um, so let's do that initially so we have a visual of who won the fight. And then what we can do is we can go ahead and interact into it, the little pit stops along the fight so we can kind of see the turn-based aspect of it, maybe even having a hit point bar that we see go down or, as the fight's going on so we can kind of see what's happening, maybe putting a little bit of delay between swings, that kind of stuff. But let's just get the right guy disappearing here. All right, so we're going to go into our fight scene manager. So this is our mono behavior in that second screen. And we want to be able to have access to the player and the monster in here, to those game objects, because the idea would be is we would probably make that game object die, disappear when the fight's over. So we're going to go ahead and this is again MVC, right? We're going to give ourselves a public game object player, public game object monster. Go ahead. All right. So public game object player, game object monster. These are both now going to be exposed into Unity. We go over to Unity here. Uh, I think we decided the green box is the monster. Oh, he is a goblin. See, AI. All right, so let's go ahead and grab our fight scene manager game object that has our mono behavior hanging off of it. And now we can drag over our player and our monster. So here's our player. And here's our monster. Oh, thought I dropped him. All right, so now we've connected to our code those two physical game objects. All right, so now we can go back into our code here. The fight starts right there. When the fight is over, I mean, the way we have it written right now, this fight is going to basically end instantly, right? I mean, it starts, there's no delay. Computers are really, really, really fast. It's just going to keep doing its thing. So we can just now see who won the fight. So why don't we do this? Why don't we pass in the player and the monster in for our start fight? So now we got to go into fight. And we've decided that start fight is going to have our player and our monster get passed in, which are both game objects. So we're going to have a game object player, game object monster. So start fight expects both of those. All right. So now what we can have in here is, I guess we could have done it up there, but that's okay. So at the end of this fight, when we have finished this fight and we know somebody has been killed, the fight is over. Before that fight is over here, we want to make sure that whoever died has now been deleted. Okay. So that means we need to be able to ask the question. We're kind of artificially pushing an agenda here because I want to show you how to ask is this particular inhabitant a player or is it a monster? So we know that if we are in this function right here, we know that one of them is dead. All right. Specifically, the defender has died. But at this point, we don't know, is the defender the player or the monster? So we want to be able to ask a question. If the defender, or if this dot, oh, is it just defender? Defender is a player. That means the player is the one who actually died. And what we want to do is we want to say player dot set active to false. Remember, our player is our game object. In fact, I'm going to actually rename these a little bit. We're going to call this player go and monster go. Player game object, monster game object. Well, because that's what they are since we are deactivating it. What we're accomplishing here is after the fight is over, either this game object or this game object is going to disappear. That's not necessary. It's just naming convention. Well, I mean, no, it's not a whatever. It's you could name it player GO or you could name it that. Would you rather have it named that? Are you going to remember what that means? Yeah. So I mean, we want our variable names to have meaningful names, right? And since we have a lot of players and monsters and things like that floating around in here, it might be helpful for us, especially since we're sometimes dealing with instances of C# objects and we're sometimes dealing with instances of game objects, for us to give ourselves a little hint at the end of those. So, I mean, you can choose what kind of naming convention you want to have, but player GO for player game object, or if you want to spell it out, you could say player game object. That's fine too. You know, now it's very clear to us what we're actually dealing with. So if it is the player, then we're going to say player game object set active to false. He's going to disappear. Otherwise, it must have been the monster. And actually, you're seeing it's showing you a different way of destroying a game object. I'm going to ask you this here in a second. Monster game object. So if it's the player, we're doing that to that game object. If it's the monster, we're doing something slightly different. Just looking at the code based on your guess, what would you guess is the difference between those two? Go ahead. Yeah, so the first one, if we set a game object's active to false, it's still there. We could always turn it back on at some later point in time. If we destroy it, it's not still there. In our case here, it probably doesn't make a difference, at least based on our current level of planning. But this scene is likely going to go away after a fight is over, so it probably doesn't actually matter whether we just make him invisible or destroy him, because when the scene goes away, he's going to be destroyed anyways. So in this case, you can kind of decide which is the one you want to go with. I don't know that there's even a preference. So here, we'll leave them both in, then we'll just say hide the player versus remove the monster from the scene. Pick your poison. All right. So now, during our fight, we have access to the game objects, the representation of our monster and our player, our physical representation. And based on who actually dies, we're going to make them no longer visible one way or another, either destroying them completely or just hiding them. All right. Where is my... Seems like it's not happy with something. Well, I'll just get my error out here. Expected something or other. Oh, I must not have closed a curly brace up here. So if it's dead, if this, else this. There we go. All right. So this little thing right here is the thing we're introducing here. So I'm going to actually go ahead and open up Keynote. Is keyword. In Java, this is called instance of, if you've come from a Java background. This allows us to ask, so this is a Boolean operator. So this is a Boolean operator that allows us to ask whether a specific instance of an object is of a certain class type. So the syntax for this would be object instance is class name. As an example, player, the player is player. The player being an instance of the player class, player being the name of that class file. This guy would return true. I'll put that down on the next line. If the player is an instance of the player class and false otherwise. So this is a powerful thing, especially when you're considering abstract classes like we have here with inhabitant. So let's just use an arbitrary example of what if I had a list of inhabitants. And right now we have two different flavors of inhabitants. We have players and we have monsters. If I were going through this giant list of inhabitants, so we kind of think of this like Santa's bag, I can throw different kinds of inhabitants in there. I can throw players, I can throw monsters. I can't throw inhabitant because I can't create an inhabitant, right? Inhabitants are abstract. I can't create instances of them, so I shouldn't find any plain Jane instances of inhabitant floating around. But I should potentially be able to find plenty of players and monsters. So I can throw players and monsters into the Santa bag of inhabitants. But now later on, if I'm going to go start searching through this, it might be handy for me to say, well, when I pull this generic inhabitant out, I can ask, are you a monster or are you a player? Maybe I'm going to do something different with you depending on which of those two things you are. Make sense? Now you get back to this idea of using generics, though. What if I want to create a list of inhabitants, I would set the generics as inhabitant, which then would mean when I take something out, it would come out as a generic inhabitant, even though we know it's either a monster or a player. That's where this is keyword comes in, where it allows us to say, are you a monster? Are you a player? And do something accordingly. Okay, so it's a new Boolean operator for us to make those decisions. Let's see, somebody said something. Okay, I think we answered Caleb's question already. All right. Let's go back in here to the code. All right, so now we are making the loser disappear one way or another. All right, so let's test this. Okay, now this is going to happen pretty quickly. Is this guy? No, come back to that later. So whoever died, okay, monster died there, so it should say, yeah, Mike killed the goblin, monster died. All right, let's try it again. I died that time. Goblin killed Mike, player died. All right, so clearly it's doing the right stuff, but this doesn't feel very video gamey, right? You know, what we'd like to have is maybe have kind of a hit point bar above them where we can see them going down as the fight is going on. Yeah. I guess whatever you want. I mean, it could be a number. That's fine. Just some sort of visual indication. So this will be, you can decide as the implementer how you want your combatants, your inhabitants here to show their current condition, if you will. You could even do color changes if you want. You know, you could go from their current color to, kind of a darker shade of it or something, but whatever you want is fine. So let me make sure this is saved and then let me articulate the homework. All right, so the fight between player and monster is working, but completes instantly. We want to create the impression that the fight is happening over some period of time. Maybe there is an attack every 1 second, something like that. If you want to change that to something else, that's fine. But I'm kind of thinking, one of them tries to attack. We see either an adjustment in their health or not. Then a second later, the other one tries to attack. Boom, 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 boom. And maybe after 7, 8, 9 seconds, somebody keels over. Somebody disappears. Okay. But you can mess with this time frame to your liking. So update the program to allow the fight to spread out over time as described above. Think about some hints. So right now, if we look at our code, the entire fight is taking place inside the start function of our mono behavior. right here. We need this to be experienced over time. So we need it to be represented in update. So by representing this in update, we can't just move f dot start fight into update, because then we're going to basically do an entire fight per frame. I guess we could have them turn themselves back on if we don't destroy and just have this flicker effect where they're fighting each other. But we want there to be a single fight. So if I'm giving you some hints on doing this, we'll say move the fight mechanics into update and utilize things like time.delta time to deal with the amount of time that has occurred since the last call to update. Maybe after there's been a second of time. So if you remember back to our original tutorial when we dealt with time delta time, when we ask time delta time, what it gives us is the amount of time, probably in milliseconds, since this guy was last called. Well, we want to wait for maybe 1,000 milliseconds or 500 milliseconds before we make our next attack. All right. So that's our hint for that, is I think you can use time delta time to determine how long before you tell the next guy to take another swing. So I'll throw another hint in there. Maybe have start fight be reimagined into multiple function calls in the fight object, where we call attack every 1 second and then check. So instead of it just being in this while true loop that just goes zips through, we do the first attack. They live or die. We do wait a second, do the second attack, third attack. Each time we switch who's the attacker and who's the defender. Make some sense? All right. I'll push my current version of the code up. So this is due on Monday. I'll see everybody on Monday. Take care.